I think we can get started. So hello everyone, and thank you very much for joining us today for our webinar, Discover Scaleway's Serverless Solutions. Before we start and before I introduce you to your speakers, just a few housekeeping items. As you all know, this is a webinar and you are all on mute, but that does not mean we don't want to hear from you. So please feel free to submit any questions you may have in the question tab, and you should also engage with us in the chat tab that you see on the upper right corner of your screen. The webinar will be recorded and you will all receive the recording tomorrow. And with that, it is my pleasure to introduce you to my colleagues and your speakers for today. So it's Laure Piekelko. She's the product marketing manager for Kubernetes and serverless here at Scaleway, and my colleague Lucas Merdinian, who is a product manager for serverless. Laure, Luca, I'll hand it over to you.
Hi everyone, we are really pleased to have you with us today. So here is the agenda for the webinar of today. We're going to talk a little bit about Scaleway and what is Scaleway. Then we make an introduction about the two serverless products, serverless function and serverless container. After that, we're going to browse a little bit the serverless use cases, and at the end, you will be able to ask all your questions and to talk with us. So, to talk a little bit more about Scaleway, Scaleway is a European cloud provider. We have more than 20 years of experience in building infrastructure. We are now more than 400 people that working on building the cloud of the future. We have 3 different brands that aims to browse a lot of services. So with the Scaleway Data Center, we provide private infrastructure and data center co-location. We also have Dailybox that aims to provide dedicated servers, and our new range is public cloud ecosystems that browse a lot of services through IaaS, PaaS, and now with serverless. So our public cloud ecosystem is truly innovative, and we are sovereign. That means that all our servers are based in Europe, and this is something really important for us. And we aim to develop services that will help developers to create great architecture and infrastructure. Now we are more than 40 different products within our public cloud ecosystems that goes from compute services to network services to also storage. And we are really proud to launch our new product, serverless function and serverless container, 2 weeks ago. So we're going to deep dive a little bit more into the serverless ecosystems, and we're going to explain to you a little bit what is our serverless product. For us, serverless solutions are really important because they are a new way to build more faster, some microservices architecture, but they are also more cost-effective than other cloud resources that are on the market. When we wanted to develop serverless product, we had 3 different ambitions. The first one was really to offer a European alternative to the solutions that exist on the market that are mostly American and Asian solutions. So we wanted to propose a new product for European developers that want to use European solution. We also want to fulfill our public cloud ecosystem with microservices-based application solution in order to help the developers that work with us to create more innovative architecture and to help them to build microservices service. We also want to fulfill our portfolio with these 2 products that we didn't have that will probably help the developer to browse all the range of the product of the public cloud ecosystem from Scaleway. Who is the biggest target for serverless solution and who will use them. We also wanted to create serverless solution in order to target organization and developers that want to focus a little bit more on business logic development, but also who want to create microservices application and people who want also to free themselves from operational tasks and who want to build application more quickly by automatize some tasks. We also want to propose a truly automatic scaled product. And because we truly believe into the fact that we have to create the future of cloud, we also want to have a product that scale from zero and that is a pay-as-you-go service. So with serverless, you will be able to only pay for the resource that you will consume. Now that we browse a little bit about Scaleway and serverless ecosystem, we're gonna deep dive into the two products. We're gonna start by talking about serverless function, and then we're gonna talk a little bit more about serverless containers. So serverless function is a serverless services that will help you to run code without having to maintain or configuring any infrastructure. That means that you will have zero infrastructure management. You will only put your code within the Scaleway console, and then your code will run depending on your workload. These services scale from zero. That means that when it's not used, it's like a sleep mode, and then when the code will be run, it will scale from zero. That also means that because it scales from zero, you will only pay for the resources that you will use. If we deep dive a little bit more on the main feature of a serverless function, we support different runtime, Node.js, Go, and Python. The product is fully integrated within the Scaleway console, so that means that you can use it into UX-friendly ecosystems. We are serverless.com framework compatible, but we also add features that help you to easily port your AWS Lambda within our ecosystems. Our serverless function products responds to HTTP and Chrome triggers, and the product is fully scalable. Now Luca will gonna explain to you a little bit more how does it work behind it.
Okay, so the product is built. Okay, sorry for the sound problem. So the project is built around Scaleway's product. So we used Knative hosted on our dedicated capsule cluster. So Scaleway's products, which run on Scaleway's instances. And the product is divided into three parts. The build part, which enables you for functions to upload your code and build it. So you upload your code through the API, the serverless framework, or directly in the console. It's built with Tekton and stored into our own container registry, which you can see in the console. And then the serve part. Okay. The serve part is we provide you an URL, an HTTPS URL with automatic TLS encoding subscription, and when someone made a request on that URL, and the Knative part creates as many pods as required, and pull your container from the registry and deploy it. On top of that, to enable you to monitor and to follow how your containers and functions are working, we deploy a metric stack. So on the console, we will see later, you can access your logs, your application logs, and a few metrics to understand if your functions are running correctly. So talking about the billing, serverless is as Laura explained, pay-as-you-go services. So a bit like every solution, for functions, we pay for the request that you make, how many times you invoke the function over a month. And regarding, and the second part is the memory consumption. So you build on a tier, resource tier that you choose. So how it works is the first request you have a latency that's called in serverless the call starts. So it's when we're starting the pod for the first time, it's the time it takes to pull your images, to code from the registry, push it on a node on Kubernetes. And so once the function is warm, which is approximately in T1, the function starts to process your request and your build for as long as the request is being processed. Between two requests, we can wait up to 30 to 15 minutes for the last pod. And after that amount of time, which is not built, your function shut down and it's go back to zero. To prevent you from having this call start latency issue, we add the possibility to provision function, which means that you can set up a minimum scale that, and we will keep function warm or keep function up to handle your function faster. So when we convert that into pricing, so we've got a free tier of 1 million requested and 400,000 of gigabytes seconds per month per user, and then it's 50 cents of euro per million requests and 1.2 euros per 100,000 gigabytes second. The amount you pay to keep your function warm is a fraction of the price for the random function is 36 cents per 100k gigabytes second. So the table, we got 4 memory tier, and this is the price per 100 milliseconds. So the minimum price you pay for the request when it's made and compute. Switching back to Laura for serverless container.
So we're going to now present to you serverless container. So serverless container is a new way to easily run your container without having to maintain any infrastructure. It's quite the same as serverless function, but you switch out your code to a container. So that means that you can bring your runtime, you can develop any languages within your containers. You will have no infrastructure management. Your container will scale automatically depending on the workload that you will have. And as for serverless function, you will only pay for the resources that you will use. The main feature of our service serverless container is that we offer you a flexible configuration. That means that you can put any languages, any library within your container, and then it will work. You can easily leverage your container workflow because your container will be running as soon as it needs. The scaling will change based on your incoming traffic, and we will provide a load balancing services add-on on serverless containers. We also respond to cron and HTTP triggers, and as for serverless function, are fully compatible with serverless.com framework.
So the two products are based on the same basis, and we also use for containers our capsule running Knative. But as you deploy directly your container, you push directly your container to the service. The build part is not included. So you build your container on your computer or using the GitLab CI or even the serverless framework which enables it. And then you push it to a Scaleway container registry, and when a request is made to your services, it will, so Knative will pull the images and push it onto a pod. The bases are the same, and as Laura put it before, the thing that is added by container is that you can run any workload you want, provided that it's a stateless service. So for containers, the pricing is a bit different because as you're more free to do whatever you want with the container, we won't bill you for each request that you're doing. We are billing you on the running time of the container, and the other difference with function in the running is that you can have parallel requests processed by the same container in functions, and that's the point of serverless function. One function, and you have an amount of resource that is reserved, and when you made a request for a function, you have all the resource dedicated to your function. To container, in order to be more versatile, you can use your containers to process several requests if you want, or only one if you want. The maximum simultaneous request is 80 per pod, containing instances, and so we will build the usage as long as the container is up and running. And you can also set up container running all the time, and they will wait and be built as long as they are running. You can process back more long-term running applications and processes. And in any case, if there is more requests as it's serverless, the new pods will be provisioned to answer the load. So you can have a basis of consumption and a basis of resource provision. And when on peak demand, the product adapts itself to the demand. And the pricing is a bit different. So we are charging you on the vCPU tier and the memory that you reserve. There's a 200K vCPU per and 400 gigabytes of memory free, and then it's €1 per 100K of CPU and 10 cents per 100K of gigabytes second. So now switching to the use case, we are going to show you two use cases, one using functions and one using containers. So for functions, you can use it to perform asynchronous tasks, such as integrating third-party services, which connect, for example, GitHub and Slack, using serverless function and webhook. You can process file or process data stored on S3 or on object storage, or even in a database, SQL database or PostgreSQL. You can use it combined with IoT Hub, which can help you process data coming from IoT objects or IoT loads and route them to serverless functions. And you can also, which is interesting, automate your IT operations. So, for example, manage your instances, then automatically perform backup on your Scaleway instances, manage the image you got in your registry, or anything that is accessible through Scaleway API or Scaleway SDK. So now for a demonstration of a classic serverless pattern, so we're going to process images stored on a bucket in object storage. So the bucket, we're going to do it, requesting the bucket from the all image from the bucket, and then call as many functions as required to process the images. And each image transform function will pull images, transform them, so it's the operation is a simple resize, and then put the total image to the destination bucket. First, okay. Sorry, so first we are on Scaleway console. So as you can see, this is the bucket scan function in one of my namespace. Here is the URL we call. The functions are status ready and hosted in Paris, so I can call the function here. Wait for the time, so it will scan the bucket and see it's in the logs here. I have my function is based on an in scale of 1, which means that it can answer the question, the request faster. So I have 1 active instances. I should see here a little spike in this CPU as my resource is not really CPU intensive, and a higher spike in memory usage. And here a first spike that will appear for the request I've just done. So the function is listening, and the function has called, as you can see, there's in my bucket different type of objects. We got HTML files, TXT files, and sometimes PNG files or JPEG files. So the functions filter out, and then we'll call my function image transform to resize the images. So this is the image transform functions, and in the log, wait for it to appear. So you'll see there's a pike of 20 functions that has been instances of my function that have been called, because the batch function called the function as many times as needed. And so we can see highest spike in CPU and memory usage. And regarding requests, this is the request per second. So between 1 minute, we got many requests in second, and now it's back to 0. And so for the log, everything has been listened to. Now, this is my 2 buckets. So the source bucket with 16 objects, and this is the destination buckets, and all images has been renamed, resized to fit the requirement. So if we got time, oops, I can. It's okay. I can show you a bit so to upload the code, I use the serverless framework, which is a tool that enables me to upload several functions at the same time with the same parameters. So it's streamlined. It's an easier way and a simpler way to deploy functions and to work with functions. So the function is developed in Node.js, and we are using, as you may see here, if you notice, the same patterns as in AWS Lambda, so that you can easily port your applications. So you got the event objects that enables you to pass information, and the context object. So this is the simple the bucket scale, which use the simple AWS SDK and the list object bucket v2. And in the image transform, so we get from the event object the query string parameters key, which is the key of the source key, of the image in the source bucket, and then we perform the transformation using the sharp library. Switching back to the presentation. So with containers, you can basically do whatever you want with a container that has a web server inside, because as we're using Knative and as we are using serverless workload, we have to have a way of starting your container, of knowing that you want to use the container. So this is done through HTTP request or later event processing. And with your containers, you can host any website or API or microservices that you want. You can use them in the same way you use function, but to perform different operations, different batch scheduled tasks using the cron jobs feature. And this batch job can be data processing, because you might want to use different library, not the default library of Python or other languages such as R or Scala. You can want to do multimedia processing using, for example, FFmpeg to transform videos, and you can do it also to generate documents if you want to automatically create reports on data, PDF reports. You can use it using containers. So for this is a very basic demo. We just pull an image from Bitnami Docker Hub, push it on Scaleway registry, and deploy it on serverless containers. So as our applications need to be stateless, we have to persist data and files. So we use a MySQL managed MySQL DB as Scaleway and object storage to store and persist information. So switching back there. So this is my container, so I deploy it. The process is really easy because once the container is in the registry, you just have to choose the resources and the scaling. So now to prevent from having latency, I choose to have one instance running, and also the application is for demo. I have a maximum of 20 instances running, but I can put it to max 1 in order to, for example, prevent and limit costs. And I can also limit the maximum concurrent execution, which means that, for example, if your set is to run exactly once and perform operation one at a time, you can just limit this part. So I can set environment variables, and so I just deploy my containers, and the blog here, the WordPress is running, and I can have access to image that store on object storage. There. So that's it for the demonstration. Now, what we want to do and what we would like to do in the coming month and in next year is we have 3 main objectives for these 2 serverless projects. The first one is to make design and deployment easier. For functions, it means that we want you to be able to do more things with functions, adding runtimes, for example, PHP or Java, to enable you to do the application and the services you want to do with the product. We want to better integrate in your CI or CD to enable simple deployment, simple coding of serverless function. The second point, and for container, we're going to enable you to not do the minimum adaptation of your container to push it on your application, which means that for now, for example, we are working on enable you to put any port, listening port on your container directly from our application. The second part is the integration into serverless and Scaleway ecosystem. We want you to be able to manage your resources Scaleway easily with serverless, to communicate with them better. It goes through the implementation of events in the product, so bucket notification using or DB notification, being able to post any event within Scaleway ecosystem into serverless. So company work, and we're working, and we start working on it at the beginning of next year. And the final point, which is aligned with Scaleway view of the cloud, view of the multi-cloud, is to unlock multi-cloud serverless workflow. The idea is that you can use Scaleway's containers, Scaleway functions to process events from a Kafka or RabbitMQ that you have stored, that you have hosted on Scaleway or anywhere else. The idea is to enable you to have the technological bricks that you want and to use it with the product. So that's it for the presentation. We are now going to review
a different question, and we're going to try to answer to all your different questions. So, first one, can serverless code access database SQL or NoSQL?
Okay, so yes, serverless functions, you can, provided that there is a way to code this function in the language that you provide in the runtime, so in Python, Node, or Go, you can call any database you want. If you go to the tutorial section of the documentation website of Scaleway, you'll find code samples and for PostgreSQL in Python and the SQL.
I will copy paste the link to the documentation into the chat section.
So the second question is threatening only pay for the resources. If like this, this is expensive than normal instance or cheaper? Depending on your use case, I have seen in the chat. If you have a sporadic load, if your function or container is not called every day, or if it's called only sometimes, it will be way cheaper because as you pay only for the functions and as we provide resources that are really lower than what you can find in any other instances at Scaleway, the cost will be cheaper. There's example of serverless use case or serverless good story, not at Scaleway, but general story of applications that runs the millions of requests per month, and that only costs €4. And if you go on the console in the coming weeks, we're going to add simulators to enable you to simulate price based on the resource you choose, the minimum scaling you choose, and the amount of requests you're going to do per month. Okay, so the next question, is it possible to manage the waiting time 30 seconds before shutdown? If yes, what's the maximum time? So the maximum time is 15 minutes for the last pause. For example, if your function has 4 instances running, the three instances will shut down after 30 seconds, and last one will wait up to 15 minutes. It's not possible to manage the waiting time for the moment, but for functions, it's totally free. The next question is, can we use Pred registry, or should we have Docker image in Scaleway Docker repo? Are we charged for those images saved? Okay, so for now, you need to have your images on the Scaleway Docker repo, so Scaleway registry, and you are for containers, for functions you're not charged, but for containers you are charged for the resource and the storage that you use. But and there's 75 gigabytes of storage free on Scaleway containers, so you can upload many images there. AWS is notoriously known for generating huge invoices when accidentally overused on scale. We have a way to not let users go into overdraft. So that's a thing we are starting to think about. Now you can okay. Okay, so I have a short internet loss, connection loss, and you can monitor your billing day to day in Scaleway's console. But the point is good, and we are going to add it to the roadmap. Alexis, do we have a way to retrieve the logs, Dolly log export for further analysis? For now, logs are only accessible through Scaleway's console, but I'm taking the part on this. We are going to start working on improving our logs, and this is able to download the logs. So the category asked, do you know the average call start time for the serverless functions? It depends on the from the test we made, it depends on the tier you choose. It's between 5 seconds and 10 seconds, I think. But we are also working on improving it to match what we can see in the on the market. Does container able to connect to other VPC to connect with service hosted on other instance through virtual private network? VPCs and private networks are a bit new as Scaleway. The public gateway, public network has been released a few weeks ago. You will soon be able to connect your DB to private network. For serverless, this project will start next year, but for now, not yet. Regarding Python, Go, and Node.js, how you handle dependencies. So you cannot upload dependencies on your through the console. You have to go either through the API or using what we recommend the serverless framework. So basically, you put all your dependency in for Node the Node module, for Python in the package files using pip, and then you upload everything the package files to the server to our through our API to serverless function, and it will be deployed using all the dependencies. Once again, you can find it in our documentation in the serverless function how to package your code page. Is API already available to the serverless services as IAC? Not sure what IAC is. Infrastructure as code. It's coming. It's coming now. You can deploy serverless using Scaleway CLI, and I think that the dev team is building the Terraform integration. Do you have plan to offer some interoperability with others serverless.com, with others cloud providers to resume easy multi-cloud management? I don't think I understand what you mean by that, Jerome. Do you mean being able to deploy serverless functions or serverless containers along with other resources at other cloud providers? Not sure to get it. If you can put the question in the chat, maybe. I was typing. Oh yes, the question is using similar APIs tools to manage serverless functions. Yes, we are for now compatible with the serverless.com. In the demo, I don't know if you've seen the demo, but to deploy the demo code for the bucket scan and the image transform application functions, I used serverless framework. So yes. So if you have any question, feel free to post it in the question side or in the chat.
Okay, so don't forget that you have a feature with serverless, so don't hesitate to try the product right now. Our product is available within the Scaleway console. We will put you the link of the product into the chat section, so you will be able to try it really soon.
Okay, so thanks everybody for attending the webinar. And if you want to reach us, you can you can chat with us on Scaleway's community Slack and in the two channels, which are serverless containers and serverless functions.
Well, thank you, Laure and Lucas, for this great presentation. Thank you, everyone, once again for joining us. I would just like to apologize for the small audio and video issues that we have. These things happen during live webinars, so I hope you guys understand. Like we mentioned in the beginning, you will also get the recording of this webinar tomorrow. And if you have any other questions, please feel free to reach out to us. And with that, that is it from us for today. We wish you a great day, and we hope to see you at some of our other webinars and workshops. Thank you, everyone, and have a great day. Goodbye.